Anis Marzouk, 3D artist and Metaverse consultant at Innovation Factory. Hello! Today we are here to talk about how artificial intelligence is changing different industries like photography, videos and music. But now, let's look at how AI is affecting the 3D industry. What does it mean for the future of 3D? In the next few minutes, we will see how AI might change 3D. Check out the new tools in this field and ask important questions. Will 3D become less valuable? Could our business be at risk? Last year, something big happened in the digital art world when a UK startup called Stability AI introduced a new tool. This tool lets anyone, even if they are not an art expert, make a beautiful picture and art easily. But this made traditional artists like us feel both excited and worried. Stability AI's tool completely changed how art gets made. It uses just a few words as prompts to generate art quickly. This worried traditional artists because it might make our hard work and skills less valuable. Then OpenAI came out with DALL-E, Midjourney and other powerful AI tools. These tools made AI even more popular. At first, it seemed like these change would mainly affect digital and traditional art, but then Wonder Studio came along. It proposed an amazing tool that can put 3D characters into live scene with almost no effort. It can do everything like lighting and animation. These tools aren't just for art, they are changing how a lot of industry work by combining AI and creativity. ChatGPT now works with Blender, a popular 3D software. This means you can make plugins and scripts easily, so you don't have to get into the technical stuff, you can focus in your creative ideas. Sublime AI is another cool thing. It lets you make 3D stuff like objects and scenes with sample text prompts. Classic AI can make animation from video without neat, expensive equipment or experts. This makes animation easier for many different uses. Crikey for people who want to make avatars move. It lets you describe action and it makes avatar animation with AI. Luma AI makes 3D model look real from things in the real world. This is big for making games and visual stuff. The Luma AI app is easy to use. Simply take a few photos or video of an object and the app will create a 3D model in minutes. The models can be used for a variety of purposes, such as product visualization, virtual reality, and augmented reality. Polycam is an app and a software that lets you make 3D scan with your smartphone or tablet. It uses the camera and the smart tech to make 3D model. People use it in the different fields like designing and making 3D models of building and things. AI is changing creative jobs a lot, but it also makes us wonder about the future of traditional art. As artists, we need to learn and use this new tool while still keeping the essence of our work. The future has exciting possibilities where human creativity and AI can work together.
Hello everyone, my name is Moez Bouchoucha and I'm a data scientist at Talan Innovation Factory. I have been working lately on 3D, on AI models that work on 3D, to be precisely generative AI for 3D models. And the task was to generate 3D assets from different inputs, either prompts or images. And the AI have been included in different industries, one of which is the 3D designing. So for this time, we will be answering some of your questions and starting off with the first question, which is the existing solutions. First of all, the task of the 3D generation was usually done using a technique called photogrammetry. This technique is employed in softwares like Mushroom, Reality Capture, and Metashape, and so on. This method takes a set of images with a significant amount of overlapping space between them, and through some calculations and algorithms like structure from motion, which is also known as SFM, we generate a high quality output from that. Photogrammetry relies heavily on identifying the feature points, which are the tiny differences or variations in color in a picture, making the quality of the result highly dependent on the overlapping space between the images. Now, let's suppose we have enough images from different angles of our object or scene. we may still suffer from one of the photogrammetry's limitations, which is a poor estimation of the 3D object. In simpler terms, the photogrammetry cannot make good estimations for objects with small variations in color or small number of feature points, such as transparent objects or objects with highly reflective. So, to keep it simple, imagine you're trying to put together a jigsaw puzzle and all the pieces seem to be different shades of blue. Let's suppose it's the sky. And a bit like that for photogrammetry. If you don't have enough variations in the different pieces, it's like trying to complete the puzzle without all the edges. Furthermore, one significant challenge is the huge processing power and time required to obtain the final 3D result through photogrammetry. The complex computations involved in matching feature points and reconstructing the 3D structure demand significant computational resources, and this not only imposes constraints on the hardware but also prolongs the time required to produce a usable 3D model. Now, moving on to the second question, which is what are the AI solutions proposed? For many years, the task of creating accurate 3D models through AI prediction remained a challenging task until the year of 2020, where a groundbreaking AI solution emerged, revolutionizing the field of 3D generation. This innovative approach is based on the generative AI for 3D models, called NeRF, which stands for Neural Radiance Field. This model is considered as state-of-the-art in the task of 3D generation, since it is very good at representing scenes as radiance fields from a set of images from different angles, and later it would be converted to 3D models. At its core, the NeRF technique basically tries to estimate the radiance field, which is description of how light interacts with objects in the scene and how it scatters and refracts. The radiance field serves as the foundation upon which the model can generate new perspective of the scene from new viewpoints. In simpler terms, from this radiance field, the model is able to generate novel views of the scene from any viewpoint by sampling the radiance field at different points in space and direction. Finally, to convert this representation to the usual 3D models, we have to convert this continuous representation to a discrete one. So we sample points across all the scene. And this discrete representation is what we commonly associate with traditional 3D graphics, meaning this discretization process essentially converts the continuous representation into a discrete one, in structured format, and it's more familiar in the traditional 3D graphics. One important aspect of this AI technique is its ability to solve long-standing challenges in the field of 3D modeling, which is capturing reflective and transparent objects. Traditionally, photogrammetry struggled with these types of objects, but NeRF's advanced capabilities allow it to faithfully render objects like water bottles, glass, or even smartphones. This functionality has opened up possibilities for creating more realistic and detailed 3D models of a wide range of objects and scenes. In conclusion, the introduction of NeRF-based AI solutions has marked an important moment in the field of 3D modeling. The capacity of this model to describe scenes as radiance fields and then transforming them into discrete 3D models is a huge step forward, overcoming previously unresolved challenges. NeRF has considerably widened the bounds of what is feasible in 3D modeling, enabling for the construction of highly accurate and realistic representation of complex real-world objects. Now, moving on to the last question. What are the AI limitations and how to solve them? For the NeRF model, despite its huge success, this model suffered from certain limitations. One of its primary drawbacks was the considerable amount of time it requires to estimate the final result. This time-consuming aspect made it less suitable for applications where near-instantaneous results were necessary. Additionally, the quality of the output from the NeRF model was dependent on the resolution of the input images or videos, where lower resolution inputs often lead to less detailed and less accurate 3D reconstruction, restricting the model's flexibility. This model also requires a significant number of images as input to be able to generate a more detailed object. And the less data is used, the less the model is able to generate details and capture the characteristics of the scene he is trying to render. So, based on these limitations, researchers and engineers in this field tried to refine and optimize the NeRF model. One notable variation is the instant NeRF, solution developed by NVIDIA. This optimized version of NeRF solves the original model's time-consuming characteristics by delivering final results in seconds. Its speed and efficiency make it an appealing choice for designers with near instantaneous accurate results. But yet, that still have a limited resolution. So, in the pursuit of enhancing the resolution in the output, the 4K NeRF model was emerged. This variation focuses on generating high-resolution 3D reconstructions, ensuring that the fine details of the scene are faithfully captured. Now, this development opens up possibilities for application demanding reliability and faithful capture of the reality. Furthermore, to address the problem of the number of input images required to make the prediction, the SynNeRF model introduced an innovative approach within the NeRF family. Unlike its predecessors, SynNeRF is designed to make predictions from just a single image, simplifying the data requirement. Beyond these variations, many models emerge, all following the main idea of NeRF. Some are commercial and private, and some other are open source, and there are still some attempts to make better versions of the model. At this point, AI tried to capture as much as possible features from the objects or scene and estimated a 3D representation of the model. But these models are not perfect, so some adjustments have to be done, and that's where 3D designers make these changes on the output to make it more artistic and appealing to the user. This 3D generation is very beneficial for 3D designers since it helps reducing the time of designing and sculpture from hours to seconds using deep learning algorithms.
I totally get it. It's pretty nerve-wracking these days with the new automation tools popping up on the internet all the time. It feels like your job or someone else could be replaced any day. You might be wondering, what's coming next? Will I lose my job? Is my work even available anymore? Unfortunately, there is no simple yes or no answer to these questions. It's a bit of a double-edged sword. On one hand, this tool can boost creativity, brainstorming, designing, and inspiration, potentially helping the 3D industry grow faster. But on the other hand, they could also threaten jobs for traditional artists and make us question what the future holds for these professionals. Using AI instead of people doesn't mean that human worker will be replaced. It means that job will change, possibility becoming more efficient. We already see the happening in software development. Similar change might occur in the 3D modeling and design. Instead of one person doing all the work, designers will use AI to work faster and be more efficient. Designers will still have control over what they make, but they will use a different tool. This new tool might let them focus more on creative tasks. AI could be a big help for 3D designers, making their work more efficient. The question is whether we are ready to accept this change in our jobs at the early stage, or if we resist machine taking over of our creative process.